Assalamu alaikum wa rahmatullahi wa barakatuh. This is Physics Week 4 AMS for those doing the AMS. So this is the quiz. A loop ABCD is rotating between the poles of a permanent magnet. Which of the following are true? When ABCD is horizontal, the rate of the flux change through the loop is zero. This is because, as you can see here, it's horizontal like this. So it still didn't change. So the rate is zero, not the flux itself. The flux itself is a max, but the rate of the flux change is zero because it did not move. When ABCD is vertical, the current through the loop is zero. That's obviously wrong. The current generated in ABCD is called an alternating current, yes, because it changes its polarity. The current through the galvanometer changes direction twice every complete rotation, yes. All of this is mentioned in the book. The frequency of the generated current is double the frequency of the loop's rotation. This is logically wrong. Next question. Please do read the book. It's not that much. Just make sure to read the book. In a transformer, the primary coil carries an alternating current. You should know this. Alternating current, which creates an alternating magnetic field. The variable magnetic field induced in the secondary coil is a variable. The variable magnetic field induces in the secondary coil a variable electromotive force, which is the EMF of the same frequency. Always, when we have transformers, the frequency is constant. Okay, frequency is constant, and when the number of coils, when the number of coils decreases, this is a step down. When the number of coils increases, this is a step up. Okay, so just keep this in mind for future questions in the quiz. Next, okay, so obviously you should know this for the periodic. Alternating current is the one that has the slip rings, and DC current is the one that has the brushes. Next, okay, a coil is rotated. Okay, whatever. When is the surface perpendicular? In the book, it's mentioned that when it's parallel, the EMF is a maximum, and when it's perpendicular, this is the sign of the perpendicular, the EMF is a minimum. EMF minimizes. Okay, so they're telling you, when is the surface perpendicular? It's when the EMF is zero. So where is that? That's at A, and that's at C. Okay, so A and C. When is the surface parallel? It's at B, and it's at D, because we know parallel means maximum. Where is the maximum? At D and at B. Here it is, BD. Moving on. Which of the following statements are true about a simple AC generator? Again, you should know this for the Morse periodic. The current is removed from the coil via twin ring commutator. Yes. In a simple generator, the magnet rotates. The magnet rotates? No. An AC generator can contain either permanent magnet or electromagnet. Yes. An AC generator can contain either slip ring or slip ring commutator. No, that's not wrong. Split ring, sorry. That's wrong. If the loop of the generator moves uniformly, the current generated varies according to the sine function, yes. Okay, moving on. And name the parts of the transformer given the function of each. Okay, so we have which one induces the EMF. You should memorize this. It's written in the book. Please, it's here. You should go over the book. So induces an EMF is the secondary coil. Helps in making the magnetic field of the primary coil with the secondary coil is a soft iron core, which allows the magnetic field to flow. We can say helps in generating an alternating magnetic field is the primary coil. Next. Okay, as here they're asking if it's a step down transformer or step up. I told you when the number of coils decrease, it's a step down. As you can see here, it was in the primary coil 760 and the secondary coil it's 100, so it went down by 660 turns, so it's a step down transformer. Moving on, question number 8. A transformer has 60 turns in the primary coil and n turns in the secondary coil. So it has here in the primary coil 60 turns. The peak EMF in the primary and secondary are 48 and 240 volts respectively. What's the number of turns in the secondary coil? Okay, to do part A here, you have to do number of turns of the primary over number of turns of the secondary equals voltage primary over voltage secondary. So the number of turns in the primary, which is 60, over number of turns in the secondary coil, which we don't know, equals the voltage at primary, they told you it's 48 over 240. So 48 over 240, so basically that's 1 over 5. Hold up, I think I did a mistake real quick. Wait, let me just plug it on the calculator. So 60 times 240 divided by 48, you get 300. Yep. So it's 300 turns. So NS is 300 turns. Okay, so that's how to do it. You cross multiply and you get it. Moving on, let's see. The current in the primary coil is 4 ampere. Secondary coil is 0.72 ampere. What's the input power? Okay, so we know the input power. Real power is P equals IV. Okay, so I need for the input, so I need the primary. So the primary voltage is 48. The primary current is 4 ampere. So therefore, P input, it's equal to 48 by 4, which is 192 watt. For this one it's the same thing, so 0.72 times 240, so power out is 0.72 times 240, which is 172.8 on the calculator watt. To find the efficiency, you need to do power out over power in times 100. So let's do it on the calculator. So power out is 172.8, and then power in is 192 times 100, you get 90% efficiency. So that's how to do it. Question number 9. This you should know as well from before, that I instantaneous it's equal to I max. It's equal to I max times sine 2 pi ft. Okay, so the peak value, which is the I max, it's given already, 45. The frequency, we can get it here. They're telling you, whatever is inside here, 18.8 T is equal to 2 pi ft. So 2 pi, they told you use pi as 3.14, so 2 times 3.14 times f times t equals 18.8 T. Cancel T, cancel T. So basically to find f, you need to do f equals to 18.8 over 2 times 3.14. Sorry for the bad handwriting. Okay, so let's plug on the calculator. So 18.8 over 2 times 3.14, you get 3 hertz or 2.9 or whatever. Question number 10. Okay, here to find the RMS current or whatever, you just do I RMS is I max over root 2. So let's just plug it in. So the I max is 20 divided by root 2. It's 40. Next, select the graph that describes the current. Okay, so basically here they're using brushes, so that means that it's a DC. So it's not changing. It's not changing. It's not going in the negative direction. So it's this one. Okay, you guys should know this. Okay, here efficiency again. We need to do power out over power in times 100. To find the power out, which is a secondary coil, I need to do P equal IV here. But the I, it should be 0.162 because it's from milliampere to ampere. So 0.162 times 110 equals the power out. So power out equals, let me check, 0.162 times 110, it's 17.82. So and then for the power in, we need to do 2.2 times 9. So 2.2 times 9, which is like 19.8. Yep, 19.8. So 19.8 watt. Then 17.82 over 19.8 times 100. So let's do it real quick. So 17.82 divided by answer times 100, you get 90%. Okay? So that's the efficiency of the transformer. This question is important for the periodic tomorrow. Which statements describing an oscilloscope are true? It's a monitoring device used for visualizing varying voltages. Yes. A beam of neutrons? No, it should be a beam of electrons. Two pairs of charged parallel plates are used to deflect the beam. Yes. It's connected between 2 points across which the voltage is to be studied. Yes. A fluorescent material is used to accelerate electrons. No, it does not accelerate the electrons. The front screen of an oscilloscope is imprinted with a grid. The horizontal scale is time, the vertical scale is voltage. Okay, again, I'm going to go through this quickly. The coil through which an AC is passed is a primary coil. The coil in which an alternating EMF is induced, secondary coil. The current passing through the primary coil, primary current. EMF induced in the secondary coil, secondary voltage. Please go over the book. It won't take maybe 15 minutes. An ideal transformer is connected to a 220 volt 50 hertz supply. The primary windings have 100 turns and the secondary windings have 2000 turns. The output voltage of the transformer. Okay, so to do this again, we need NP over NS equals VP over Vs. Okay, so Ln primary, which is 100 over 2000, is that 2000? Equals 220 over V secondary. So let's go on the calculator really quickly. So 220 times 2000 divided by 100, 4,400, yeah. Okay, so question number 17. If a secondary coil has more turns than a primary coil, then the transformer is a step-up transformer, as I mentioned before. And question number 18. When the transformation ratio is less than 1, the transformer is called a step-down transformer. Question number 19. An ideal transformer has a primary and secondary coil, secondary coils of 160 and 4,800 turns. The AC voltage at the output of the secondary coil is 270 volt. What's the voltage connected to the input of the transformer? Okay, so again, I need to do NP. Let's make it NS over NP. So NS over NP equal VS over VP. So basically NS, which is 4800 over 160 equals to 270 over VP. So to find the VP, you do 270 times 160 divided by 4800. You get 9 volts. Moving on, question number 20. I mean, this has been many quizzes before, so I'm just gonna quickly give you a moment to look at it. Moving on, here, the RMS of the current in the loop. Okay, so we know that this value is the maximum. So to find the RMS, I do the maximum divided by radical 2. So 14.1 divided by radical 2, you get approximately 10. The frequency of the current, so we know here also we need to do whatever is here equal to 2 pi ft. So 16 pi t equal to 2 pi ft. Cancel pi, cancel pi, cancel t, cancel t. 2f equals 16, so f is 8 hertz. Moving on. At time equal to 0, the surface of the loop is parallel. Yes, because it's maximum. So time equal to 0, it's a maximum. 15 perpendicular, yes, because it's 0, so it's a minimum. Okay. If the resistance of the loop is 0.08, then the RMS value of the current of the loop. Okay. So I have V. They want the RMS of the current, so be careful. Now, let's take a point, for example, 0.10. 0.10. Okay? Where this is the time, this is the volt. They told me the resistance is 0.080 ohm. To find I know it's V over R. So therefore, 10 over 0.080 why did I take this? Because they want the RMS value, so I want the maximum voltage. So maximum voltage means maximum current. So 10 over 0.080. So it's 125 ampere. So it's 100 ampere. To get the RMS, I just divide this value by radical 2. And that's it, 88 milliampere. Milliampere because we're working with millivolts here. Next, this question is very important. So please focus with me. The transformer has 300 turns in the primary, 50 in the secondary. Primary current is 5 milliampere. Current in the secondary is 27 milliampere. Okay. The efficiency in the transformer. So obviously I need the power, but I have a problem. I don't have the voltage here. So let me just take this here. Okay, so now I know that VP over VS equal NP over NS, right? So VS equals VP times NS over NP. We all agree? Yep. But I know that this NS over NP, it's 50 over 300. So NS over NP is 50 over 300. So which is 1 over 6. So basically this is VS equals to VP times 1 over 6, right? VP. Let me just write it properly here. VP times 1 over 6. Okay. I know that P out. Sorry. Okay, so to find the okay, hold on. So P out equals LV secondary times LI secondary, where PN is equal to LV primary times LI primary. Again, sorry for the bad handwriting. So to find the efficiency, I do, as you all know, I do P out. I'm just gonna write PO over PI times 100. So therefore, it is IS times VS over IP times VP. I just substituted the values from here into here times 100. But I know that VS is VP over 6. So therefore, IS times VP over 6 over IP times VP times 100. VP cancels with VP and the 6 goes down, so it becomes IS over 6 IP times 100. Substituting the values, so IS which is 27 over 6 times 5, which is the IP, times 100, you get 90%. Okay, very, very, very good problem, very nice question. Based on the number of turns, it's a step down transformer because it went from 300 to 50. Next, a step up transformer increases the voltage of power source. Yes. An ideal transformer does not change, obviously, because it's ideal. A real transformer decreases the output power. If a transformer increases output voltage, it decreases the output current, because we know, like, with the current and with the current and like the current and the voltage, they just go opposite to each other when it comes to the transformer. Okay, that's it basically. Last question. Okay, so this really, it's primary coil, laminated core, secondary coil. The process by which changing current in the primary coil causes a changing current in the secondary coil is electromagnetic induction. This you should note. The frequency of the current in the light bulb is 60 Hertz. The thing about it is, here you should know by heart that the frequency in a transformer is constant throughout. Okay, so that's the end of the video. If you have any questions, please send me, and thank you for watching. Good luck.